Sorry about network challenges. Now we have gone back a little, but let me go back and extract out. There's a way I can find out my extraction. Okay, so far I had derived as far as showing you that 6 pi r eta into V1 minus V2 is now equal to V times the charge out of the separation. Then you can make the charge the subject and say it is 6 pi r eta into V1 minus V2 times X divided by the PD across the plates. But remember, we had already derived what R is, whereby R was 9 eta V1 divided by 2G open brackets rho minus sigma. Okay, and all this was raised to power half. So one can make charge the subject as 6 pi. Then where you have R, substitute 9 eta V1 divided by 2G into rho minus sigma. All this raised to power half times V1 minus V2 close brackets times X, all divided by the PD across the plates. So this is what can give us the value of electronic charge. If you don't want to use that, you can as well go ahead and say electronic charge can also be attained from 6 pi into brackets 9 eta V1 divided by 2G into rho minus sigma close brackets power half times V1 minus V2 all divided by the electric field intensity. Why? Because the electric field intensity, remember, is V over X. So when you have here X up and V down, it means you have divided by the electric field what? Intensity. So it is from this relationship that Milkans found out that charge is always equal to NE, whereby charge is always a multiple of a basic unit of electronic charge, 1.6 exponent negative 19. Thus, the charge carried by a simple electron is 1.6 exponent negative 19. A simple electron is an electron, of course, which we assume is only one, and we assume it has a charge of 1.6 exponent negative 19. Then a dropping charge of NE was either for standing in to mean that the charge which you have on the entire oil drop falling is the number of charges it has times the electronic charge, which could have been either too many or too few. Thus, he concluded that the charge is always quantized. So there is always a question which they ask in that conclusion I've written down, as you see there. They can ask you to explain how Milkan's experiment proves that charge is quantized. Those two conclusions can predict that solution. That Milkan's experiment always can prove that charge is quantized. You use those conclusions he suggested, and then you explain that charge is quantized. Okay, so with that, there are some precautions taken when carrying out his experiment. One, a non-volatile oil should be used to prevent evaporation, which would lead to variation of the mass of the oil. If you use a volatile one, it easily vaporizes and the mass of the oil will reduce. So you assume the mass of the oil is remaining constant. Then secondly, the apparatus. Here we are. The apparatus should be surrounded by a constant temperature bath to stop convectional currents, which would lead to variation of the viscosity of the air. So one who was wondering, why do we use a constant temperature bath? So that we do not vary the viscosity. Because if we have a different viscosity, you've seen rain of late. when rains start falling and there is a storm in them, the wind you feel blowing to you is not the same wind you feel when there is a sun. So, or when it is shining. So for that reason, to have a constant viscosity, we use a constant temperature bath. Then if the PD is such that the droplet moves upward, then the viscous drag will always have to follow downwards or to force downwards. Reason being, a viscous drag is frictional force. Frictional force experienced by a body falling through a viscous fluid. When the PD is such that the droplet is stationary, then the viscous drag is not there, because the viscous drag is only experienced when the body is moving. Friction is only experienced when the body is in motion, in this case. Then when the density of air is neglected, then upthrust is always zero. Sometimes we say neglect air buoyancy. It means upthrust is supposed to be what? Zero, as we shall see. So it is from there that we shall now come in and handle calculations. Let's see if someone has a question. But before we come in for calculations next week, can we all have at least those notes derived, those notes written down, and then the derivations made perfectly well, so that we can be in position to answer Milkan's oil drop experiment questions when they are set. Any questions? Okay, if no questions, I've sent you the write-up. Please summarize it.
Thank you, teacher.
You're welcome.